Last week we did actually 4.4, basically finish it, but I would like to do one more question and the variation of this question. The problem from our textbook, this one, number 29, is actually the easy one. But after this, then I will go over the harder part. Okay, but still something you should expect. Number 29. As of this writing, the Mega Million lottery is run in 44 states. Winning the jackpot requires that you select correct 5 different numbers between 1 to 75. And in separate drawing, you must also select the correct single number between 1 to 15. Now, the question is, find the probability of winning the jackpot. The jackpot is that you select these 5 correctly and the correct single number correctly. Okay, so if we try to imagine that we have 2 boxes actually, instead of only 1, we have 2 boxes. The first one, we have 75 numbers, okay, and you need to select 5 of them correctly. And the second box, there are 15 numbers, 1 to 15, and you need to select 1 of them correctly. Now, of course, there's only one jackpot. Okay, there's only one way for you to win the jackpot. So probability to get the jackpot is equals to only one way divided by the number of ways you can select those numbers. Okay, only one outcomes that give you the jackpot out of so many possible outcomes. Now the thing is, how many possible outcomes do we have? We will compute it this way. How many ways can you select 5 from 75 choices? Then the number of ways you can do that is 75 combination 5. Okay, now keep in mind that you need to write this 75 and 5 as subscript, smaller and lower. Okay, so there are 75 combination 5 ways to select 75 numbers, to select 5 from 75 numbers. And then on the separate drawing, how many ways can you select 1 from these 15? Well, there are 15 choices, you select 1 of them. There should be 15, right? Okay, should be 15. But we can write it this way, 15, choose 1. So the probability for us to get a jackpot will be 1 over the number of ways this can happen. That is 75 combination 5 times 15 combination 1. Okay, now in some of my tests, maybe even more, the recent one, I only asked you to write the notation and you don't need to use calculator. Okay, you don't need to use calculator and convert it to decimal, no need. You can just leave it like that. But suppose I want you to compute this. What will this be then? And let's see, 75 combination 5 is, ooh, that's a big number. That's 1 over 172, 593, 90 times 15, choose 1, I believe is 15. So this is equal to, the probability for us to win a jackpot is 1 out of 258,890,850. That's the probability. Now, if you try to make it into decimal, of course, that's not a nice number. Okay, that's 3.86263 times 10 to the negative 9. But I do not accept the scientific notation as your final answer. I need you to write it in decimal. That is 0. Notice that this is to the power of negative 9, right? Means the 3 is at the 9th decimal place. The 3 is at the 9th decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, which if we round to 5 decimal places only, that's basically 0. Okay, now it's not to say that it's impossible for us to get the jackpot. Okay, but the probability is so small such that it's next to 0. This is what we say is next to 0. Okay. Now, what we learn here is first that to win a jackpot, there's only one way out of these many ways. Then the second thing we learn is how to compute how many outcomes we have here. Okay. Now, this type of question you can see a lot in different elementary statistic and probability textbooks. But the following question is considered hard by a lot of instructors and of course for a lot of students, including a lot of tutors, the following questions. But with proper understanding, it is actually something you still can do. Okay. Let's confirm. We need to confirm that there is only one way to get the jackpot. Okay. In other words, when we say this is one here, there's only one way out of these many ways to get the jackpot. Okay. We did it by intuition. Like we feel, oh, there must be only one way, but it is true, it's only one way, but doing it by intuition does not justify, actually, does not justify us getting that answer. Okay, well, I can accept that there's only one way, but then I can vary this question later on such that your intuition doesn't work anymore. So one key notion I need to emphasize on you is, okay, feeling is important. But not valid to justify our argument. Okay, at least in math, simply because you feel that's right doesn't make it right. Okay, in fact, I heard some people kept on saying that feeling that fact doesn't care about your feeling. Okay, it doesn't matter what you're feeling. Fact that won't change. Okay, simply because you feel it is right doesn't mean it is right, and simply because you think it's wrong doesn't mean it's wrong. Okay, now you don't want me to to project my feeling to you, saying that, I don't feel that you do it right and therefore you are not right. No, you don't want me to do it that way, right? Okay, so since you don't want me to project my feeling to you as a judgment, as the way me judging you, then you should not do that also. And on the top of this, of course, saying that there's only one there, even though earlier is okay, now let's look deeper into it. Okay, And hopefully, sometimes by us analyzing a case deeper, then we find a better way to solve even more problems. Okay? Now, how do we know there's only one way to win the jackpot? Let's break that box, those boxes, even further. Notice that originally we have a box with 75 numbers, right? You need to select 5 of them, okay? And these 5 that you select, of course, you hope to be the correct one. So 5 correct numbers, and of course, the other 70 are wrong one. Now, in the second box, you are told to select one number, and that one number hopefully is the correct one, and the rest, the other 14, must be the wrong one. Now, you will win the jackpot if you select 1 from here. I'm sorry, 5 from here, and of course, nothing from here. From the second box, you select 1 from here and nothing from here. Think about it again. We have 2 boxes, the box of 75 numbers and the box of 15 numbers. Now, we need to select 5 from the first box and 1 from the second box. Now, the thing is, you will get the jackpot if your selection of 5 happens to all of them from the correct one. Okay, and your selection of 1 from this 15 happens to be the correct one. Okay, that's what you need. Now, if you select 5 correct one here, it means you select nothing from the wrong one. Is it right? Because you can only select 5 from here. You can only select 5 from there. Okay, so if 5 of them correct, then none of them wrong, right? Likewise, for this case here, the second box, we are told to select 1, and you want that to be the correct one. Okay, if you happen to select 1 from the correct one, it means you select nothing from the wrong one, right? That's just a consequence. That's just a consequence. Okay, now then, therefore, how many ways can you, the number of ways to get a jackpot? That will be 5 choose 5 from this box. Okay, and then times 70 choose 0 from this box, times 1 choose 1 times 14 choose 0. Which, when you compute using your calculator, you will see how many ways can you select 5 items from 5 items. There's only one way, select all of them. Yeah, you can check with your calculator, but n choose n is always 1. N choose n is equals to 1. And choose 0 will also be 1. How many ways can you select nothing from 70 objects? Well, one way, don't select anything. Okay, so you will get 1, 1 times 1 times 1. There's only one way. That's how we confirm that there's only one way to get the jackpot. So if we look back into that probability question, what is the probability to get the jackpot? That's, we can write it as 5 choose 5 times 70 choose 0. That's from the first box, right? Times, you know, my line is way too high, times 1 choose 1 times 14 choose 0 over, now for the from the first box, 75 choose 5 times from the second box, 15, choose 1. Okay, that's how we get that 1 times 1 times 1 times 1 over 258,890,850. Okay, that's the probability which is next to 0. Okay, that's why if you win the jackpot, of course, you should celebrate with me, right? Okay, we should celebrate together. Just with me, fine. I mean, you don't need to celebrate with the whole class. You know, and yeah, sharing is caring, right? Okay, now let's look back to this question. This question is a question that all statistics instructors are supposed to be able to answer. Now, however, not a lot of instructors, as far as I know, last time I still talk to most instructors. I mean, it's been a while that I don't really hang out with instructors at East LA College. I'm a full-time at West, so I'm really busy there, right? But at West in the past, I was really close to most of them. And I found out that only 2 or 3 other instructors knows how to do the following question. Let me show you the actual Mega Million. Okay, let me share with you the website. This is the website. Mega Millions, how to play. So the book actually had that version of Mega Million that was like around 6 or 7 years ago, maybe 5 years ago. Okay, not sure. But right now, the structure of this Mega Million already changed. Okay, the way it is being played is that players will pick 6 numbers from 2 pools, 5 different numbers from 1 to 70, and 1 number from 1 to 25, which we call the gold mega ball. Okay, let me screenshot this and put it back to our notes. So you want to count cards? You better know how to do it heavily here. Okay, this is the current Mega Million structure. So instead of 75 numbers, you select 5 numbers from 1 to 70. And from the second box, you select from 1 to 25. Now, when you say do easy pick or quick pick, basically you let the machines doing that for you, but the machine will do basically this thing. Okay. Now, what I want you to do the easy one first. And I give you maybe 1 or 2 minutes just to write the notation. Okay. What I want you to do is to compute, find the probability. So part A, find the probability to win the jackpot. Let me give you 1 minute or maybe 2 minutes, including writing it down, to think about the notation. You don't need to use your calculator. Just write the notation the way I wrote it up here. This one here. Write it this way. Okay, write it that way. Now let me go back. Now let me give you 1 or 2 minutes for this. Okay, let's start. Okay, maybe you are not done yet. Very likely, if you're not done yet, then maybe you get stuck. Okay, let's do the story all over again. You have 2 boxes. The first box has 70 numbers. You will select 5 from there. Okay, and the second box has 25 numbers, you will select 1 from there. Okay, so the number of possible outcomes or number of choices you can make will be 70 choose 5 times 25 choose 1. Okay, so the probability to get the jackpot will be something over, maybe I write it, number of way to get jackpot. We know there will be 1, but let's slow down a little bit. Divided by the number of outcomes. How many ways can you select? 5 from the first box of 70 numbers and 1 from the second box of 25 numbers. Okay, now the number of outcomes we have computed, that is 70 combination 5 times 25 combination 1. Now we know the number of jackpot is only 1, but let's find out, confirm. Now in the first box, there are actually 2 categories of numbers. The first one, the category of the correct numbers, okay, and the other 65, the wrong numbers, okay, the non-winning number. In the second box, there's one of them correct and the other 24 is wrong. For us to get the jackpot, I need to select all 5 from those 5 correct numbers in the first box. And notice that in the first box, we can only select 5, right? So once I select 5 from the correct one, then I cannot select anything from the wrong one. Likewise, in the second box, for me to get the jackpot, I need to select all correct one. There's only 1 there. But consequently, I will not be able to select any numbers from the wrong one. Now, writing the coding here, that will be 5 combination 5 times 65 combination 0 times 1 choose 1 times 24 choose 0. Okay, now you compute on the top. I give you the numbers, right? Can you tell me what's the number on the denominator? Use your calculator, please. We will check if our answer is correct. But Thomas, it's not from textbook. How do we know the answer is correct or not? Don't worry, we have our way. I get 70 choose 5 is 172, 593, 90 times 25, which will be 1 over 431,484,750. That's the probability to get a jackpot. Okay. Now let's check our answer. Let's check our answer. Why I get it wrong? Oh, I'm sorry. It's supposed to be 270, not 75. I get it wrong. I get it wrong. My bad, my bad, my bad, my bad, my bad. Go back, go back, go back, go back, go back. That's right though. Oh, hold on, hold on. I type it incorrectly on my calculator. This is incorrect. This is incorrect. This is incorrect. I still have that 75 from the previous question, I guess. Am I recording this? Yeah. So that's incorrect. It's supposed to be 12103,014. Okay, times 15. That will be times 25, not 15. See, I keep on making it wrong. Times 25. That gives me 302,575,350. Okay, that's 117 million something. That's 75 choose 5. That's the number we have above, I believe. Yeah, 75 choose 5. But no. It's already become 70. Okay, and as I try to show that to you here, the jackpot and the rest of the possible outcomes. Give me a second, I screenshot that for you. This is the probability. Okay, the probability to win a jackpot is 1 in 302 million something. Right? Okay, so my technique is correct, but my computation was wrong. I put in wrong numbers. So my notation here is correct. I just happen to put 75 choose 5 to get that 17 million something. Okay, now what I want to emphasize is that's the technique. Okay, that's the technique. Now the thing is, can we compute the probability? For example, see, when you play this Mega Million, you don't need to get the jackpot to get some money. And please don't think that way. Okay, the way you think should be, oh, you know what, I get some price will be good enough, right? If you start to lower your standard a little bit, oh, I don't mind to win this $1 million, Thomas. Oh yeah, I will be happy for you too. Okay, but can we come up with this probability? Can we confirm that's the probability? Okay, let's do that. So for part B, find the probability to have 5 regular number match. Okay, but not the mega ball. Okay, that's the case we have here. 5 regular number match, but the mega ball does not match. Okay, so what's the probability? The odds supposed to be 1 in that 12 million something. Can we confirm that? Can we come up with the same number? Okay, or can we be even more accurate? Okay, so let's start the procedure. So we have 2 boxes. The first box 70 numbers, 5 of them correct, 65 of them wrong. And the second box 25 numbers, the first one of them correct and the other 24 wrong. Okay, the probability for that to happen is equals to, the denominator is the same to the one we have before, 70 combination 5 times 25 combination 1. That is, from the first box, I need to get 5. And from the second box, I need to get 1. Okay, those are the number of ways we can get, the number of outcomes we can get. Now, but what we need here is, from the first box, we get all 5 correct, and therefore nothing is wrong. Yet in the second box, we need to get this wrong. You see? We need to get that wrong. So from the second box of the 25 possible mega balls, okay, you need to select the wrong one. That's how you win this way, this part. Okay, that's how you win that part. That's how you win the prize for 5 regular match, but not the mega ball. Okay, then the notation will be 5 combination 5 times 65 combination 0 times 1 combination 0 times 24 combination 1. Okay, so from the first box, 5 of them correct, therefore none of them wrong. Of those 70, choose 5. And from the second box, the correct one is not selected. Instead, you select 1 from the wrong one. Of 25, choose 1 way. Now, we already compute the denominator earlier. That's 302,575,350. Now, the numerator will be 5 choose 5 is 1, 65 choose 0 is 1, 1 choose 0 is 1, 24 choose 1 is 24. Okay, so the probability will be 24 over 302,575,350. Now, to have that 1 in 12 million something, to get this 1 in 12 million something, let's divide the top and the bottom by 24 so that the numerator becomes 1. If you divide the top by 24, I get 1, of course. Now, then the denominator, if you divide by 24, what will that be? I get 12,607,306.25. That's the probability. It is 1 in 12 million something. And notice that we are actually more accurate, right? Because I can even tell you what's the 2 decimal places after that. They do rounding, they do a little rounding so that people don't get scared when they gamble, right? When they do this. But if you think about this, 1 in 12 million, in decimal, that's still that's still basically 0 up to 5 decimal places. You know, okay? In decimal, this will be 0.00000079319, which at 5 decimal places, that's still next to 0. Okay, but at least we confirm that our computation is correct because it's 1 in this number, right? Notice that I give us even more accurate answers, right? I have the decimal. So it's not precisely 12,607,306. It's actually still have 0.5. Okay. Now, let me ask you to try using the same concepts. Maybe I do one more. And then after this, I would ask you to do 2. Let's say I do this one here. I do this one. Okay. Let's say I do that one. What is the probability to get 2 regular and mega ball 1 mega match? Again, we are selecting from these 2 boxes. Okay, the first box of 70, 5 of them correct, 65 wrong. The second box, 25 balls, 1 of them correct, 24 wrong. And what you need is to get 2 from the correct one, which means how many wrong? If you need to select 5 and 2 of them correct, it means they are the 3 wrong. Okay. $68. Why 68? No, not 60. I don't think it's 68. 65 choose 3 will not be 68. And then here, I need to get this one correct, so this one is wrong. Okay, so let's see. The denominator will be a total of 75 balls. From the regular one, we need to select 5. And from the second box, 25 balls, I need to select 1. Okay, we know this will be 302 million something. We did it twice already earlier, right? Now, how about the numerator though? From the first box, 5 correct, you need to choose 2. From 65 wrong, you need to choose 3. From the second box, 1 correct one, you need to select that. And the other 24 wrong one, you cannot select anything. Okay, so you see that from the regular box, you select 2 regular match and the other 3 don't match. Okay, and from the second box, you select 1 that match and therefore nothing else. Over 25 choose 1. Now 5 choose 2, as I know, is 10. As I remember, is 10. 65 choose 3, I don't know. I need to use calculator. That's 43,600 times, 680, sorry, times 1 choose 1 is 1, 24 choose 0 is 1. Yeah, I put in color highlight here so that you know which number I got that from. Okay, so then when I multiply this is 436,800 big over 302,575,350. That's the probability. Now to confirm that we do it right, I mean, we have that number there, right? Okay, it's supposed to be very close to this number, very close to that number. 1 in 693. Let's confirm. But I need to make the denominator, to make the numerator becomes 1 first. So let me divide the top by 436,800, which means I will do the same thing at the bottom. So that I get 1 over, now, 302,575,350 divided by 436,800. I get 1 over 692.709, blah, blah, blah. Okay, now if you compare with the answer we have up there, they round it to 1 in 693. That's because they round this guy here. They do rounding. Okay, so 1 in 693, the odd there, is actually not a precise number. That's after they round it. Okay, our answer is more precise, even though not precisely precise, because we have more numbers there, like 1, 3, 4, 6, for example, right? Okay, but from here we know, oh, we did it right. Okay. Now, with this said, I would like you to go back here and let me ask you to try 2 cases. I would like you to try this case here. Okay, show that the probability is 1 in that number. Okay, and then maybe the other one is this one. So try these 2 cases. Okay, try this one and then try this. Each of them should take approximately 5 minutes. Yeah. Yeah. At least you get me this notation first, and then you compute it. Okay, go at least this far. Go at least this far. Then after that, you divide by whatever you have on the numerator, and on the denominator, just round it to 2 decimal places if you want. Okay, let me give you some time for this. We come back at 10 minutes from now, 11:52, 53. Okay, try it, please. Okay, let's start. Let me work it out here, and then we compare that later on. Okay, the one on the left, probability of having 3 regular and 1 mega to match. So let me draw the box again. 70 here, right? I keep on thinking of 75. 70 from the first box, 5 of them correct. So 65 wrong. And from the second box, there are 25. 1 of them correct, the other 24 wrong. Now what we need to do is to get 3 regular one correct, which implies 2 of them wrong, because the total should be 5, right? Okay, and then 1 of the mega correct, which implies nothing wrong. So the notation will be, in my test, I will ask you to just write the notation, and you will write it this way: 70 choose 5, 25 choose 1 at the bottom, and on the top, that's 5 choose 3 times 65 choose 2 times 1 choose 1 times 24 choose 0. That's all I want you to do. Okay, but keep in mind, I don't want you to write this way. For example, 70 choose 5 like this. No, this is a wrong notation. Okay, why? The 70 and 5 should be subscript, smaller and lower. You see? Okay, that's the correct one. That's the correct one. The 70 and 5 is supposed to be smaller and lower. Anyway, let me go back and compute this. This is 10 times 2080 times 1 over 302,575,350, which will be 20800 over 302 million something. Now then, if I divide the top by, do I make any miscomputation? Where did I get that? I compute this. This guy give me 10. And 65 choose 2 give me this number. Yeah. And then 1 choose 1 give me 1. 24 choose 1 give me 1. Okay, that's how I get that. Why not 0? No, it's not 25 times 0. It's not 24 times 0. That's 24 combination 0, 24 choose 0. Okay, use your calculator to confirm. Okay, 24 combination 0. So this is divided by 20. What I mean, 20,800, 20,800. Of course, then the numerator will become 1. But what will the denominator be? 302,575,350 divided by 20,800. That gives me 14,546.89183. Okay, I suspect, I don't remember, I suspect our solution will give us 1 over 14547. Let's see if that's true. That's right. You see that? 1 in 14,547. Again, the reason they do that because they round this. They do rounding here to the nearest integer. That's how they get that. Okay? That's how. So Thomas, do we need to round it though in practice? No, you don't have to. I mean, if you want to be more accurate, then you write what I have here. Okay, but of course, if you try to market something, you don't want to scare your customer away. And you know, some of them, the reason they gamble, the reason they buy this Mega Million, because they don't know math, they don't know statistics. They never take statistic at this level. Okay, and if you show them scary numbers, they will not play that number. They will not play this game. You want them to play. Okay, but at the same time, you want to give them some information about their odds so that they don't say, oh, you're cheating me, Thomas, right? Because you don't tell me anything about the odds. I tell you the odds. They tell us the odds. Okay, what do you know about that odd is up to you. That's subjective. I give you what you need to know. Okay, the fact that you don't know what that numbers represent, it's your issue. And it's because you don't know that what that number represent, then you play this, right? That's how they make the money from you, though. Okay, that's how they make money from you. Okay, there are some people actually make money from here. Okay, but if this game is something make money for the customers, what makes you think California Lottery Commission survive until now? If they keep on giving you money, which means they themselves losing money, they won't survive, right? So don't forget, what is the reason they are in business? They want to get your money. Okay, once you know your probability and statistic, I hope through taking this class, then you know that the probability for you, even just to win that $200, even just to win approximately $200. Okay, by the way, this price actually changed over time. It's not constant. Okay, it is not constant. Okay, but knowing that your probability is that low, and that even if you win, you only get $200, then why do you want to play that? Okay, under what situation, Thomas, you will tell somebody to buy a Mega Million or Super Lotto or Powerball? First, if you have extra money and if you feel lucky. Okay, and as far as I know, there's no more other situation where when I will buy it. Okay, definitely being a lottery players is not a full-time job that you want to commit to. No, definitely not. Okay, there have been some people get the jackpot, but even those people who get the jackpot, if you trace their life within the next 3 years, you see that more than not that they actually file bankruptcy. So strange. You can get a jackpot, hundreds of $1,000,000, but then within years, you lost everything. Okay. So if you ask me, Thomas, will you recommend people to play? No, I do not recommend you to play unless you have extra money to buy, right? To buy these. Okay. If I were you, I'd rather you donate that money. It feels better. Okay. There are a lot of places willing to take your money. Okay. Union Rescue Mission, for example, American Red Cross. Okay. And of course, you can find yourself more. You can donate to the library in your city or to schools in your city, in your district, or of course to West or East LA College, right? Okay. But buying this, unless you are doing it for fun, no, don't do that. I never recommend people to gamble as a source of income. No. Okay, that's just for fun. So if you think of purchasing this for $2, make me happy for 2 days or for 1 day, go for it, right? But if you expect to buy this and then win some money, nah, don't, okay? Let's see the second one. What is the probability then to win one regular and one mega? Okay, following the same situation, I will do 5 choose 1 times 65 choose 4, because from the first box I need to select 5, right? One of them correct, so the other 4 is wrong. And then from the second box, one correct one should be selected and the other 24 should not be selected. Over 70 choose 5 times 25 choose 1. This will be 5 times, oh, what is 65 combination 4? That's 677,040 times 1 times 1 over, we compute the bottom earlier, 302,575,350. On the top, I will get 3,385,200. At the bottom, I get 302,575,350. Now divide the top and the bottom by the top. Okay, of course, then I will get 1 over something, right? Now let's see, 302,575,350. I'm missing a 0 here. Divided by that number, give me 89.38182. Now, I'm about to look at the solution above, right, from the website. Okay, but before that, I know they will do rounding, and if they do rounding, if they do the rounding, they will round it to what? 89 or 90? 89.4. Then they will round it to just 89, right? Now let's check our solution. Do you feel happy if you get it right? Now, what happened if I don't get it right, Thomas? Then try to think more, okay? Saying that I don't know it doesn't solve your problem, okay? Doesn't solve your problem. Well, this is the problem you will see in my tests anyway, okay? I almost always, as far as I know, in the last 5 years, I always have this kind of question in my test too. In fact, recently, I always put it in question number 2, the first page, okay? So please get ready with this. And this is where I will stop for this 4.4. Let me go to 4.5. Now, I assume you already watched lesson 6 so that we can go on. So I assume you have watched lesson 6 from announcement 4. Let's see again, where can you find that? Oops, give me a second. I need to change that first. So go to announcement number 4. Okay, and you should have watched this one before March the 19th. Okay, now before next week, I would like you to watch both of these. Okay, hold on. There's a chance that I actually did it wrong though. Give me a second. I need to do a big check. Give me a second. Give me a second. Actually, no. So it's supposed to be lesson 8. Yeah, so lesson 8 is the, let me change this. So lesson 8 marks the end of material for test 2. Not lesson 7. So I already have the material up to your test 3 though. Okay, so next week, please, before next week, please watch that lesson 7. Okay, and then the week after that, watch lesson 8. Now, lesson 8 marks the end of test 2, such that when we come back from spring break, we can do test 2 already. Okay, when we come back from spring break, we can do test 2 already. Okay, now let's go back to this, to the note. Where's my note? Some review. Okay, first one, notes. First, a probability distribution is a table with 2 columns. Now the first column is the outcome, the random variable. And the second column is the probability. Okay, which our textbook use p parentheses x as a function notation, probability as a function notation. Okay, second, probability of any event is between 0 and 1. Okay, cannot be negative, cannot be more than 1. So what I'm trying to say is this, that in the example we have here, notice that the second column, the probability, all of them has to be positive but less than 1. In decimal, it must be 0 point something. Okay, and then third, the total probability of a probability distribution is 1. Okay. In other words, when I add these numbers here, if this is a probability distribution, then when I add these numbers here, the total has to be 1. If it is more than 1, then it is not probability distribution. It's just a certain distribution, but that's not probability distribution. Okay, the total has to be 1. And each entry of the probability has to be between 0 and 1. Now, the thing is, as I mentioned in my lecture, the first column is a random variable. Okay, the first column is for random variable. Please don't forget, a random variable is a variable. It is a variable with multiple value. Implicitly, it has to be a number. It has to be numbers. Okay, it has multiple values. Each corresponds to a probability. Okay, so the way we read this table is pretty much as the following. Okay, it says here, 5 males of an X-linked genetic disorder have 1 child each. So 5 males, each of them has 1 child. Now, the random variable X is the number of children among the 5 who inherit the X-linked genetic disorder. Now, let's confirm first if this is a probability distribution. Okay, we cannot go further if this is not probability distribution. First, the first column, already numerical. Okay, so that's good. Next, the second column, the probability of each entry is between 0 to 1. So that's good. Okay, and then the third one, we need to check if the total is 1. Okay, so what you do is you add these numbers and make sure we come up to 1. Okay, you do it. I do it too. 0.031 plus 0.156 plus 0.313 plus 0.313 plus 0.156 plus 0.031. I get exactly 1. So it is a probability distribution. Okay, now the next thing they want us to do is, you know what, let me enlarge this. The next thing they want us to do is to find the mean. Find the mean of this random variable. The mean, also known as expected value. Or expectation. Of random variable X is denoted by mu sub X or simply mu. Sometimes they use this mu parenthesis X, but they usually don't do that at this level. Or capital E parenthesis capital X. Okay. and given by mu sub x equals to the sum of the probability times x. The sum of the probability times x. So what we do, basically, we extend this table. We extend this table, the next column to be p times x. Okay, so basically you multiply this guy times this guy, this guy times this guy, this guy times this guy, so on and so forth. Okay, so the first one is 0 times 0.031, that's 0. 1 times 0.156, 0.156. 2 times 0.313, that's 0.626. The third one is 3 times 0.313, that's 0.939. The fourth one is 4 times 156, that's 0.624. And the last one is 5 times 0.031, that's 0.155. And you add these. You see, that's the total. Do you remember how to read this notation? The sum of p times x. Okay, we learned that before on the first and second week of class. Now I will add that, this column, px column, that's 156 plus 626 plus 939 plus 624 plus 155. I get 2.5. So the expected value, or the average of number of children with that inherit this genetic disorder, will be 2.5. Okay, now how do we interpret this? How do we interpret this? If we select, or we see 5 males with this disorder repeatedly, so we sample every 5, right? 5 males with this disorder, and then you get another 5 males with this disorder, another 5 males with this disorder. Okay, then we will, or we expect, get an average of 2.5 children of them to inherit this disorder. Okay, so approximately half of these 5 will inherit this disorder to their children. Next, what is the standard deviation? The standard, maybe I do the variance first. The variance of random variable x, denoted by var x, or sigma squared subscript x, or simply sigma squared, is given by sigma squared equals to the sum of px squared minus the square for the sum of px. Now, the standard deviation is the square root of that. However, the notation for standard deviation, please pay attention, the standard deviation of random variable x denoted by, actually there's one more, they may actually don't denote it this way, denoted by sigma x or sigma subscript x or sigma only, okay, but not SDX. No, this is not. This is not a notation for standard deviation. Not a notation for standard deviation. I would love to accept that, but no, it's not. The thing is, it's not. It's not in statistic tradition, so I don't want you to use that notation. Okay, I don't want you to use a notation that is not acceptable in statistic society among statisticians. But the standard deviation, just as you expect, is always the square root of the variance. Okay. Now let me go on. Suppose then I want to compute the variance. I already have this. I already have that. But I need to find this, the sum of px being square, px squared. So I need to extend that to be with the second extension. You extend it with x squared first, and then multiply that x squared by the corresponding probability p. Okay, I hope you are following me. I'm about to give you a break, but let's finish this one first. Okay, this is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25 squared, 5 squared is 25. I get it from here. 2 squared gives you 4, 5 squared gives you 25. Now we have done this before, and in fact, you're supposed to have done this in number 8 in your test, right? The test that you just took a couple hours ago. Okay, now then multiply with the corresponding probability. These are easy. Okay, 313 times 4. That's 1.252. 9 times 313. That's 2.817. 16 times 156. 2.496, and 25 times 31 is 0.775. Now let me add all of them. I get 7.496. That's my yellow one. Okay, and this is what we have here. So what is the variance of x? Variance of random variable x will be the third number, 7.496 minus the second number square. I get 1.1 something. I'm sorry, 1.246. Therefore, the standard deviation will be the square root of that, which is 35 point, oh, I'm sorry, I got it wrong. Square root of 1.246 is 1.1. Okay, that's the standard deviation, this is the expectation, and this is the variance. Now, I hope you have memorized the formula for standard deviation for your tests. Okay, if we have frequency distribution, then the variance will be n, the first number, times the third number minus the second number being squared over n squared. Now, you can use this formula together with this, okay, where the n is actually this one. Okay, and then the sum of fx squared is basically the sum of px squared. So the formula basically the same to what I taught you before. The first number times the last number minus the square of the second number. Okay, divided by n squared. Now the thing is the n is always 1 here. Okay, it's probability distribution. So if n equals to 1, what happened? If n equals to 1, now the sum of px squared now becomes this, I'm sorry, the sum of fx squared becomes the sum of px squared. The sum of fx, now you replace that by the sum of px. You basically see this new formula. Okay, so that new formula is actually not really new. It's just modification of what we have before. Okay, now I emphasize you to memorize that formula before so that right now it's easier for you to memorize, and you can also replicate the procedure in probability distribution. Okay, now with that said, let me ask you to do this number 12. I would like you to do this number 12 together with your break, a little break, 10 minutes break. So let's come back in 15 minutes. Right now it's 12:30. We come back at 12:45. Okay, and do as much as possible to find the expected value of this frequency, of this probability distribution, and the variance of this probability distribution. Okay, so in 10 minutes we take break, and then after that in 5 minutes try to make sure, try to get at least the expected value, Okay, see you then in 15 minutes. When I had this number, I get exactly 1. Let me do it in black. Okay, so this is 1.000. Therefore, it is a probability distribution. Now, once it is a probability distribution, then we can compute the mean and the variance by extending the probability distribution. So P times X will be, this is 0, this is 0.439, this is 0.358, and this is 0.072, which when I add, I get 0.869. So the expected value will be 0.869. Now next, I will extend it further, the second extension, to find the variance. That will be x squared and px squared. 0.149 multiplied by the corresponding probability. Which when I add, I get 1.371. So the variance will be 1.371 minus 0.869 squared. The variance will be 0.615839. Therefore, the standard deviation will be the square root of that the variance is there, the standard deviation is therefore 0.78475. Okay, now what we have done in the last two examples, we verified that we get a probability distribution, and we extend to find the expectation and the variance, and also standard deviation. Now, let's do more problems from here. I think there's one more problem I would like to do from this section before I will do problems of my style. Okay, the problems, I see the problems we have in our textbook is definitely not enough. Seems like this author talk about probability, but don't really want to deal with probability. Which is not good though, because when the topics after this, after probability, requires heavy knowledge on probability. Okay, let's see number 26. In the Ohio Pick 4 lottery, you can bet $1 by selecting 4 digits, each between 0 to 9 inclusive. So we have 4 digits, each from 0 to 9. Okay, so there are 10 choices for the first digit, 10 choices for the second digit, from 0 to 9, not from 1 to 9. 0 to 9, there are 10 choices. Okay, and 0 to 9, 0 to 9. Okay, and so it means there are 10,000 outcomes. Oh, that's actually part A. Okay, now part B, what is the probability of winning? Well, if you select one of these 10,000 outcomes, which happens to match with the outcomes they did, then you win. Okay, so what is the probability of winning? The probability of you winning will be 1 out of 10,000. Okay, part C, if win what is your net profit? You will make net profit will be, you get $5,000, right? But that's after you spend $1 buying the ticket. Does it make sense? Okay, so the question then is, what is the expected value for a $1 bet? What is the expected value of that $1 bet? Now we need to set up the probability distribution. Okay, what is the probability distribution? So let X be the net profit. Okay, the net profit. Okay, now then, if you lose, how much you lose? You will lose $1, right? Okay, the probability for you to lose $1 is 9,999 over 10,000. That's the probability for you to lose $1. So it's actually quite big probability. Okay, now, but when you win, how much will your net profit be? You will only win 4,999. The probability that you are up by 4,999 will be 1 over 10,000. Okay, so what is the expected value of your net profit? Well, the possible outcomes are -1 if you lose, 4,999 if you win. The probability is 0.9999 for you to lose, and win 0.0001. Notice that they add up to 1, right? So you do have probability distribution right now. Now, to find the expected value, what I need to do is actually to extend this, multiply P times X. Okay, so that would be -0.9999, and 4,999 times that number will be 0.4999, which when we add, we'll get -0.5000. In other words, when you play $1, you expect to lose $0.50 in long run on average. Don't forget, on average. Okay, on average, you lose $0.50. So you can play 1,000 times and expect that you lose 500. It is possible that you lose all 1,000. Okay, but what I'm trying to say is, like, if you played repeatedly many times, then you expect to lose 50 cents, which is $0.50 for each game on average. Okay, so from here we see that the expected value of X is equals to -0.5. Okay, that's our part D. Part E. If you bet $1 on the pass line in the casino dice game of craps, the expected value is -1.5 cents. Which bet is better in the sense of producing a higher expected value? Which is better to play? Is it better for you to play Ohio pick or you play craps. Now, of course, when you play, you expect a higher expected value, right? Okay. Now the thing is, expected value when you play craps for $1 when you play craps is $0.014. Okay. Now the expected value for that $1 is negative. I'm sorry. Don't forget the negative. It's negative $0.014. Okay, while when you play this Ohio Pick 4, you expect to lose 50 cents on a dollar. So which is better to play? Of course, whichever greater in expected value. So either way you will lose. Okay, it's just like who or which game make you lose less on average. Now, don't forget, those casinos, they are there not as an ATM for you to go play and get money. No, they are there to provide entertainment with possibility of making some money. Okay, but when you compute the expected value is supposed to be negative for us. Therefore, it's positive for them. Okay, this negative expected value is the expected value for the player. Okay, now if you lose, then casino wins, right? Okay, now casino makes a big money if a lot of players and they play long time and they bet big money. Okay, I told you before that I am still considered a professional gambler. Like every month this year I get invited to Las Vegas to play blackjack. Okay, and actually during the spring break I will go to Vegas. Will I play? I think I will play. You know, I think I will play. I will play just a little. Okay, but that's because they give me free rooms at Venetians for 3 days. That's why I go. Okay, but I need to measure though how much I supposed to pay for the hotel. Like 3 days, that's supposed to be around $500–600, right? So when I play with them, I will limit my loss to, let's say, $500. Okay, to make it break even, right? So that they are not that, how to say that, regret of giving me that 3 evening nights, right? 3 evening stay. But if I play and I end up winning, well, too bad. They give me free rooms and then I still make the money. But then I will be a very good advertisement for them. Don't you think so? Okay, that some people play and still win money. By the way, if you know how to play blackjack, then I can ask you this question. If you play blackjack on a deck of cards, a deck of 52 cards, can you find the probability of winning, of getting a blackjack? Now, a blackjack event is the situation where you have one face card and one ace regardless the order. Now, we can compute this already though. With what we did last week and including today, we can compute the probability of getting a blackjack already. Even better than the method we had before, okay? Because if you think about it, among that 52 cards, okay, do we have 4 aces? How many face cards? I think I should clarify when I say face card here, it's including a 10. Okay, A 10 is considered face card in blackjack. Now there are 16 face cards. There are 16 face cards. Of 52 cards, 32 of them neither or. Okay, now when you play blackjack, you will get 2 cards. When you play blackjack, you will get 2 cards. So the number of outcomes you have will be 52 choose 2. 52 cards, right? And you will get 2 cards. Now, what is the probability you get 1 face and 1 ace? Now, then you will choose 1 from here, choose 1 from here, nothing from here. So that will be 4 choose 1 times 16 choose 1 times 32 choose 0. That will be 4 times 16 times 1 over 52 choose 2. That is 1,326. That's 64 over 1324. That's 0.04827. That's the probability of hitting a blackjack. Okay, with this we can also compute what is the probability of getting 2 aces. What is the probability of getting 2 aces? If you get 2 cards, what is the probability of getting 2 aces? Then that will be 4 choose 2 times 48 choose nothing. Yeah, we choose 48 because there are 48 cards which are not aces. Right? So you look at the box right now, it's 4 aces and 48 not aces. Now you need to choose 2 from here and nothing from here. Over 52 choose 2. 4 choose 2 is 12. I'm sorry, it should be 6 here, not 4. I get 0.00905. That's the probability, not even 1%. Okay. Now, more problems. I still have 15 minutes. I will do easy problem for now. I'm sorry, this is not 4.5. My bad. My bad. This is not 4.5. This is 5.1. Not 4.5. I will do easy problem first, and then next week I will continue with harder problems. But at that time, you need to be really good with your counting methods already. Okay? Now, the one that I'm about to do right now is the case of insurance. Let's say, for example, and insurance is a case where we see a lot actually in not only in daily life to help you compute which is better when you do comparing insurance programs, right? And of course, more things to say about that. Insurance is one type of service that everybody actually buys some kind of insurance. Okay, an insurance company, you can see that they are actually making a lot of money, mainly not because they rip you off, but mainly because you don't know how to compute, so that you don't know which insurance company is reasonable, which insurance company is rip off. And of course, there are some insurance company, they just try to get your money and then file bankruptcy. They run away with your money. Okay, now let's see. For example, I use me as an example. Tom is 40 years old. I'm not 40. Let's say Tom is 40 years old. The probability survive to the next year is 0. Let's say 0.98. Therefore, the probability that I die before reaching 41 years old is 0.2. Okay, now he purchased an insurance. A life insurance for, let's say, $300 that cover his beneficiary, in this case my wife, for $400,000. In other words, I pay $300 for my life insurance per year. Okay, and in case of my death, my wife will get $400,000. Okay, now the question is find the expected value. Of this insurance for Thomas. For Tom or his beneficiary. Let me change the number. 0.98 is actually too low. 0.998. So among 1,000 people at my age, at 40 years old age, among 1,000 of them, on average, 2 will not survive to 41 years old. Now, let's see. Let's see. So solution. Okay. Now, if Tom survive, then he basically he loses $300, right? That's negative 300. Now, what happens if Tom dies? Then his beneficiary makes $400,000, but of course minus $300 that Tom's already paid earlier, right? Which is $399,700. Now let's compute the probability distribution. In case that survive, remember that the first column has to be random variable. Okay, let X be the payout or the expected value of this payout. Yeah, the payout. Now, random variable should be numerical. Okay, the probability he survived, therefore, he lost $300 will be, the probability will be 0.998. But if he dies, his beneficiary will make $399,700 at the probability of 0.002, of course. Why? Because they should add up to 1. Yeah, Thomas can only survive or die, no other way. So then, what is the expected value? Then you multiply this, right? P times X, right? This will be 799.4. And this is negative 299.4, which when we add, it's $400. Okay, so in this case, the expected value of the payout is $400 for Thomas' benefit, which is usually not the case. Why? Because if Thomas actually makes money from this insurance, then on average, right? Then on average, this insurance company lose $400 for each customers. Okay. So very likely it's not $300. I mean, in real life, okay, very likely the premium, annual premium for somebody at my age to survive the next 1 year is not $300, or another possibility, another number will be that the probability that I survive is actually higher than this. You see? Okay, because the expected value is supposed to be negative for me, supposed to be in reality. Okay, but at least right now I already show you how to compute the expected value for an insurance in case of for life insurance. Okay, now one big application of statistic that you may not be aware of, I still have like around 10 minutes, so let me talk about this. Next week I will continue from here, okay, on the harder one. Okay, but let me talk about this. I would like you to try to find out this thing, the field of actuary. Actuary is the science, actuary is a science of risk management. It is part of math, but it has a big intersection with business. Why do I want to mention this? Because actuary is one of very, very, very few field with negative unemployment. Oh, Thomas, how can we get negative unemployment? We are so scared, especially during this pandemic, that unemployment will increase a lot higher, right? Okay, but even during this pandemic, the field of actuary has negative unemployment. Basically, whoever have actuarial background, they are all employed. Now, how can that be negative unemployment? Here's what happened. Negative unemployment happens if the number of spots or employment or job spot, number of jobs in this field is more than the number of people qualified. Okay, let's say they have like 1,000 jobs available in actuary, but the number of people qualified to work in this field is only like around 900 people. But they still need to fill up this spot. So what end up happening is they hire the other 100 people without qualification. Okay, now you can try to find out what is the minimum pay and average pay of an actuary at level 1. For you to have an actuarial, to practice actuary, you actually do not need a degree. Okay, you just need to pass some tests. I passed test number 1, perfect score. They call that P-test, test on probability. And as far as I know, at West LA College and East LA College, only I have passed this test. On the top of that, I passed with 10 out of 10. Okay, no, that's not something I brag too much about. Okay, I'm just saying that if anybody want to claim that they are good with probability, they should be able to talk to me. Okay, now the second level, test 2, it's on financial math. Now, here's the thing. Let me share this with you. Did I say earlier that for you to work in this field, you don't need a degree? You need more than just a degree. Okay, to the point that they don't care you have a degree or not. As long as you pass their tests, they hire you. Okay, now 14 years ago, when I took this test 1 and get 10 out of 10, I knew that the minimum pay, if somebody hire me, is $50,000 per year. Okay, now together with my background, at that time I already studied in my PhD program at USC. Okay, the offer I get was $150K. I didn't take the job because I already get hired at West LA College at that time. Okay, when I took the test, it's pretty much the same time they did the interview at West LA College. So when I knew the result of my actuarial test 1, I also knew the result of my interview at West LA College. Now, so after that, I got some job offers, and the job offer was on average of 150K. Okay, that's because I get 10 out of 10. And with my background, so on and so forth. In fact, one of the offer was actually 150K plus 50K relocation to New York, which I don't want to take because my girlfriend at the time actually teach together with me at East LA College. Okay, too bad we break up, but that's the offer. Now, if you pass the second test, your pay increase at least by 20,000. By the way, this is 14 years ago. Okay, this is 14 years ago. What I want to say is this: I have one student from East LA College. One student, not my student, actually not my student. It's actually Mr. Huang's former students, but she asked me a lot of actuarial questions. So what happened was that she took statistics and some calculus classes at East LA College, so stats, and of course you need to go pretty far in math, right? Calculus level, calculus 1, 2, 3, and then she transferred to UCLA, and she took actuarial program in the math department. So there's a actuarial study at UCLA math department. Okay, and then before she graduated, actually I should say before she graduated, she finished, actually she passed 2 tests. Now, then she got a job offer. She got a job offer, and the package was 200K plus green card. She happens to be an international student at the time, okay? But she needs to go to work right away in 1 month. So she had only 1 month to prepare before she starts the job, while she still needs 3 months to finish her study. You know what she did? She took the job and said F to UCLA degree. Have you ever seen anybody like that? Like plenty of you, and maybe me too in the past, look so high to UCLA degree. Like, well, that person graduated from UCLA. What does he do now? What does she do now? Oh, well, she's still looking for a job. Okay. But this lady, she got the job even before she finished her degree. Unfortunately, she was told to choose. If you take the job, you need to quit your study. Okay. If you want to continue your study, then you cannot take this job. The one she actually stared at is the green card. Okay, she knew that she can just graduate first and then look for other job, but the fact that she got green card offered may not come twice. So she took the job and she said F to UCLA. You know, she still don't have her degree, and she said doesn't matter, I got the job. And Thomas, my job pays more than you right now. So the way she talks to me before that, the way she talked to me is like very, very respectful. Okay, which I of course appreciate. I don't mind, you know. But after she got the job, the way she talked to me, like just like friends, and it's like, hey, you know what? Your tone, the way you talk to me is different. And then she said, oh, Thomas, it's because my pay is better than you right now. I said, oh, that's good for you, right? And I'm happy for her. Okay, I'm happy for her. Okay, the purpose of your education is actually for you to get a better job. So your goals are not supposed to be in the degree only, but what comes after that. Okay, there's no point of you get a degree from MIT, for example, but you're unemployed. Okay, no. In this situation, of course, we have good reason, right? But in long run, that's not what our degree for. Okay, so don't tell me where you graduate from. I prefer you to tell me how much you actually put to your family and contribute to your society. Okay, because you getting a degree is you are sucking resource away from your society. You need to give back at the end. Okay, your job is not, your purpose of this in living in this society, not only to learn something and just absorbing, just take. No, you need to give back. Okay, that's why I appreciate her more. It doesn't matter how her attitude to me, right? But she already makes something, at least give back to her family, and of course, paying some tax. I expect that, and she can do more, of course. Okay, yeah. Now I hope you look into this, especially if you already taken some calculus level classes. Look into this. Okay, this is a very, very good resource. And I'm talking about at least 3 of my former students changed their field to actuary, and all of them, all 3 that I keep track with, by the way, all 3 are female. Okay, all 3 of them are female, and all 3 are doing very, very well, financially. And one of them is actually purchasing her second house right now, and she is not even 30 years old yet. She works at in San Diego. Well, anyway, this is where I will stop. Next week, we will continue on 5.1, but please watch lesson 7 so that we can go on to 5.2 and 5.3. Okay, so next week we will continue on this 5.1 and then continue 5.2, 5.3. Please watch lesson 7. See you then next week.